Hello and welcome to another tutorial. So this time around we are going to be writing some deliberately bad code because we are taking a look at the area of something called exceptions and exception handling. So in order to do that, we need to make some code that's going to have problems. So let's dive right on in. And so exceptions are a really valuable tool. There's a lot of exception stuff that already you may have run into. And so we're going to, firstly, before we start looking at how we can catch and handle exceptions, how we can throw our own exceptions, we want to first get an understanding of what actually happens to our code when an exception occurs, because this is something that's actually really, really important to understand. So first thing I'm going to do is I'm going to call this bad code 1. And so this is going to be code that will intentionally cause an exception. So I'm going to attach this onto our poor cube that's going to have to run some very terrible code that I'm about to write. So what I'm going to do is I'm going to do this in start. There's a couple of things I'm going to do. So prepare to run bad code. And then let's have another debug log here. I ran the bad code. And then let's look at a couple of different exceptions that we can potentially cause. So one of the ones that we will run into just so many times in Unity, it's an unavoidable one. It's the most common one that we run into. I've been working with Unity for a very long time now, and I still consistently run into it because it's such an easy one to overlook. So it's one of the easiest types of things to have occur. So I'm going to set up something where this could link to the transform of some other object, linked object. So I'm going to, setting it up like of this, it's going to think that it's one that's getting configured in the inspector. So it's not going to cause any issues with me trying to use it. Because then I'm going to go, okay, well, linked object dot rotate, and let's, pick 100, 100, 100. It's not really going to matter what angles we use there because it is going to not be happy with us. And that's the intent. So we want to see what actually happens when we run this code. So we're going to run it. Causes an exception, and again, unassigned reference exception or null reference exception, those are the general ones we're going to hit. But we'll notice we got our first debug log, we did not get our second. And this is something that is critical to understand with exceptions, and why, if your code is causing exceptions, I very, very, very strongly recommend you do not add any more code until you fix those exceptions. Because testing your code while there are exceptions happening, not all of your code is running. When an exception hits here, it exits the function at this point. It unwinds the call stack is what we would say. So it doesn't ever run this code, which means depending upon where in our code that exception has occurred, we could have large sections of our code that have not run. We might have done a little bit of a setup side of things, but never done any of the actual work with it or the cleanup side. You can imagine if we had reserved a resource, something like of that, we're never then cleaning it up afterwards. So an exception changes the behavior of our code. And that is why if your code is causing exceptions, stop writing more code and fix those exceptions. Do not keep adding more code to it until you have sorted those out, and maintain your code at a level where there are 0 exceptions happening, because they are quite serious and they change the behavior of our code. So really, really important thing to understand. If an exception occurs, it does not run the rest of the code. you are in a indeterminate state then with the project. And that is very, very dangerous because you have no control reliably then of what state things are in and what's happening. So that's the first thing. So this demonstrates bad code that causes an exception and that is going to, not run any further stuff. This was at a fairly high level here. It's, we know it stopped the start function. What if that exception occurred internally within a function? So if I have a function here that I'm going to call bad function, and I'm going to do this rotation in here, and I will call bad function. So we want to see what the behavior is there, because again, an exception could happen very deep down in our code. It could happen several functions deep quite easily. So we want to understand what are the upstream effects that it has there. So we'll run this, and what we will see is it's exactly the same. When an exception occurs, as I said, when it unwinds the call stack, and it keeps unwinding. It keeps going up and up and up in the call stack until you hit a point where something handles that exception. So this is something we refer to that when we raise an exception, when we throw an exception, we can also handle that exception. We can catch it. So it will just keep unwinding the call stack and keep interrupting the functions until it gets to a point where that is handled. Now, Unity obviously has, and we can kind of see with this, it happened in our setup here. We can see where that exception occurred, and there's further bits to this call stack that we can't see, but essentially above that start function, there is something that is catching that exception. So that means if we had something that was nested 10 layers deep, and it's only at that very top layer that the exception is handled, that means we don't just have one function that we have, left partway through. We have every function in between, which means we could have a lot of things that are in a indeterminate state. This is the danger in not handling exceptions, and that's why I want to really emphasize that point. Please, as soon as you see exceptions, track them down, fix them. Don't leave them there. It will just cause much more of a problem later on to fix it. Fix them early and immediately. They are critical issues that are very important to fix. So that's what happens when an exception occurs. Now let's start to look at what we can do about it. Because exceptions are a very good thing. They're an error that is really emphasizing the seriousness of the problem. And there are actually some sections of code that they're designed to use exceptions. So a good example where you'll often see this is things that are doing communications. So something like communicating to a website, network communications. The way those stacks, those segments of code are typically structured is that they rely on using exceptions to indicate problems. So that's something about their design. They're generally designed in that way. I will generally make use of exceptions when it is something where it's a case of this is a critical error. This is something that I need it to be escalated and treated super seriously if it occurs. So I will use exceptions in cases like of that. Otherwise, I'll generally use a log error. So for me, the different levels of how I approach stuff is, okay, if something is a problem but is not going to cause instability, then I might use a warning. If something's an error but still it's going to cause bad behavior, but it's not going to be something that is critical. It's usually something where something isn't linked up. I'll use an log error. If something is absolutely critical, if it's something where it's a case of it is not safe to continue doing any processing, this needs to abandon at this point. And I'm not trying to keep the project up and running at that point. It's a case of, nope, I need things to know that this is bad, this is broken, must be fixed now. That's where I use exceptions for. So that's my approach. Different projects, different places you work are going to have different approaches, and that's okay. There are definitely variations there with it, and there's no universal one right way, except the one thing that I will say is absolute: if there are exceptions, fix them. Don't leave them sitting there. So we know what happens when an exception occurs. We know the risk there involved in it. Let's look at how we actually catch and handle those exceptions. So what I'm going to do is I'm going to set up another script, and I'm going to call this exception catching. And this one, we're going to, again, have stuff in it that's going to cause an exception, but the difference is going to be that we will catch that exception. So how this works is, and I'm going to actually do a very similar setup where I'm going to have that. But what I will do is we have this concept of a try. I'm just going to actually put the entire block in. We have this thing called a try catch. So what we do is put a debug log here, attempting bad code, linked object, rotate 50, 50, 50, ran bad code. And here, debug log, code caused error or exception. So try catch is a way of working with things where we know it might cause an exception, and where we actually really need to know about the content of that exception. As I said, generally where I would use this is in cases where the exception is expected and we want to handle it. So things like communications to a website. I want to catch the exception in that case because I want to either present information to the user saying, hey, there appears to be a connection issue, or I might need to fall back to different behavior. So that's the cases where I would be using things like a try catch. I wouldn't use it with just carte blanche in every single bit of code of like, well, this could cause a problem, I'm going to put a try catch there. No, that's not the intent. The intent is we're catching it when we actually really need to, when we are wanting to specifically handle and work with that exception. So let's see what happens in this case. I've got that code attached, and we will run this. And I'll just turn off bad code 1, so we're only getting the output from our new one for the moment. So we'll run it, and attempts bad code, code caused exception, and then the exception still appears here with the call stack. And it still appears here with the call stack because we rethrew it. So that process of, in C#, causing an exception is referred to as throwing an exception. So by putting a throw here in the catch, what it does is it actually rethrows it. So this allows us to grab that exception, potentially do some cleanup here now. So we could do some specific staged careful cleanup, or we could do some specific error messaging, things like that. We could check the type of exception that's occurred, and we might only rethrow in particular cases. Because if I remove now that throw, what we'll see is we don't get that unassigned reference exception message there. So the exception has occurred, but we don't know because we didn't throw it. So this is not something that I recommend doing, except in cases where, again, that web side of things, I would use that for, I would not rethrow those exceptions because I'm specifically handling them. So let's look at some more stuff of what we can do here. Because we've got this type, well, let's actually change this. So we've got a variable here, and then we can actually plus ex dot, we can see there's ability for us to provide things like help link, stuff like that. We can provide our message. So exceptions have information in them like the message. We can access stuff like the stack. These can be really handy extra bits of information to be potentially logging out. So this is stuff where you could take that exception, put that out to a log file, things like that. And we can see our message has been able to be output. We can do a little bit more here. So because we know the particular type of exception that's occurring here, we're getting an unassigned reference exception. So we could say catch unassigned reference exception ex, and then we can handle that specific case. So debug.log error, and exception was caught and handled. So what this will do now is if we get an unassigned reference exception, then we're going to display a particular message. Otherwise, we just rethrow it. So let's run and see what happens in this case. Because what we were expecting is to see that we don't get the exception line, but we do get our error line. So we can catch particular types of exceptions here. But then what we're doing is a really nice process here where, okay, well, that's for the unassigned reference one. What if I did something here that will also cause an exception where transform, temp transform is equal to null, and then do temp transform rotate 50, 50, 50. So this is not now an unassigned reference. This should give us a null reference exception. So because it's not one that we're specifically catching, this should then get rethrown. So we'll run it, and we can see it does rethrow it. It goes through the normal exception handling logic. So this is a really powerful way of, okay, well, as I said, in the case of things like our web communications, there might be specific exceptions that, okay, we'll catch this exception and we'll catch this one and we'll catch this one. And each of those we do a very specific handling for. But then we have a fallback, a catch-all setup essentially where, okay, well, if it was some other type of exception, then we just allow that to throw using the normal exception handling logic so that we don't actually, avoid missing those problems. So really, really powerful in that case. We handle our specific areas and then we let everything else be handled via the normal exception handling logic. So, okay, that's pretty cool. That's how we can catch and manage and handle exceptions. And this would work even if this was in a function. That would still work exactly the same. What I would generally say is you want to try and catch the exception as close to the source of it as possible. Going back to that example before where we had something 10 layers deep, you don't want to catch that exception in that top 10th layer because there's so many areas of code that have had to unwind. So what I would generally do is trying to catch it as close to the source of the problem as possible. Now, it could be a case of you catch it in each one and rethrow it back up, but you also could catch it fairly low down and then safely transition the other things out of the particular problems. So try and catch exceptions as close to the problem as possible. That means it minimizes the potential for corruption and uninitialized data and things being left in a bad state. So, okay. Seen what exceptions do. We've seen how we can catch and manage them based upon the type of the exception. Let's look at how we create our own. Let's throw an exception. So, going to turn off that script because we're going to create one for exception throwing. And so this will handle kicking off an exception. So we have, with this, the way we throw an exception is we just do throw. And then we need to give this an actual exception. So we need to do a new. So for example, we had the unassigned reference exception. And you'll see in terms of versions, we can provide that with just an empty thing. We can provide that with a particular message, or exceptions can actually have another exception nested within it. So this can be handy if we want to catch an exception and then we want to throw a different one. We can actually then wrap that original exception in the new exception we're throwing by providing it there as the inner exception. Again, really handy approach, allows us to get a lot more information and a lot more data. Now there are a lot of exception ones available. We've got Unity's various ones. We also have under system a lot of exception ones here. So if we search for exception, we can see there's a lot of built-in existing ones. So there are ones here that if you are implementing something, see if there is already an existing exception that you should throw. So for example, we've got ones where there's so many different ones, but things where we've got like null reference. So if you've got that scenario where some data is null and it's trying to be accessed, you could throw that exception. We've got specific ones here for invalid operations, numbers. So there's a lot of exceptions already available there. If there is an existing one that matches the purpose of what you're actually working with, use that. Use the existing exception where possible. That means then if there's already some proper handling further up for that particular one, that it could catch it, also means that it's giving you a clear indication of what the particular problem is. So in this case, I'm going to say, I'm going to throw an invalid operation exception. And I'm going to pass in a message. And what I'm going to say here is intentionally throwing exception. So as soon as I do that throw, any of the code afterwards is not going to actually run. And we'll just put in a debug log, did not run. And we'll chuck in another one here, about to throw exception. Just so we can see that life cycle, and we can see it's actually already telling us. It knows this code will not run because it's seen that throw and it knows it's not going to run. Similar to what we'd see if we put in a return or something like that there. So it knows it's never going to run, but we're going to leave it there just so we can see the behavior. So let's run this and we should see our exception appear down in the console, and you can see our message is there. So we know how to throw an exception now. We know how to catch an exception. We know the things that exceptions do in terms of how they impact the flow with our code. Well, let's look at creating our own custom exception, because we might not be able to find an existing exception that fits. There are a lot of ones there in that system namespace. There's a lot of ones there that Unity has available. But there might not be something that covers our specific case. We might have a need for setting up our own specific exception, so we can do that. So I'm going to create a script here, and this is going to be for custom exception throwing. So we'll set up a custom exception. So public, so following conventions for this, the class name should end in exception. Demo custom exception, and it must inherit from system.exception. So public class like that. Exception with a capital E. Now, there are 3 constructors that every exception is expected to implement. The first is an empty one, demo custom exception. This is the first one that we are expected to implement. So in this case, doesn't need to pass in anything extra, so we don't run any of the stuff with our base one. We will, oops, it's supposed to be that. We can run our base one if we want. Now, so we've got our initial empty one. We also must have one that has message, which again, we then run the base version with message. And then we have a final one, string message, and then system.exception inner exception. And again, that runs base, message, inner exception. So these are three constructors that are expected to be there for any custom exception that we create. So make sure that we set these up, because this means we're following the same convention as every other exception, which is good. Now we can add in our own then custom data and things like that if we needed to. So we could have a setup where, okay, public demo custom exception, and alongside our message and inner exception, we might also then have, maybe this relates to a particular file or something like that. So we could have string file name. Now again, we still run base one with the message and inner exception. But what this means is we can then do stuff with that file name, for example. So we could have that stored, string file name. So we could then just be setting that file name is equal to file name. That means we can throw that exception and provide additional data in an additional context. Because then down here, when I need to throw that, I would go throw new demo custom exception, and then I could be providing test. Well, there's no inner exception, so I can provide null test.txt or whatever extra information we needed. So we can add an additional data there, and that's really handy if we were catching this, and when we caught it, there was particular information we were looking for. It might be a file, it might be a position in a file, it might be an asset, or some extra context. We can provide that there. Because when I run that, what we'll see is it will throw that exception, it'll appear in the console, which is what we want. So we'll add in our custom exception throwing. So what I'll demonstrate is throwing this exception and then catching and looking at the data from it. So we can see it's correctly thrown that exception, which is good. So let's catch this now. So try, and I'm going to keep that sort of set up, where what I will do is put the throw here. Oops. Put the throw into our try. And then I'm going to catch that exception specifically. I'll keep my general sort of fallback block there, but what I will have is a specific one for demo custom exception. Debug.log bce.filename. And if I make that public, then that will be accessible. So what this will mean is I can throw that custom exception, I can catch just that and get data from that. But any other exceptions just go through the normal process and will appear down here. So we'll let this run. You can see we caught it and we display the particular area that's a problem. So this allows us to attach and fold in extra info. So as I said, if you can use the built-in custom exception ones, I do very, very strongly recommend using those. The difference there, or the exception there, is if we are needing to provide additional information, then absolutely set up our own custom exception classes. So when we're setting up our custom exception classes, we do need to have these 3 constructors. It's not enforced that we have to have them, but convention is that you do have those 3 constructors as a minimum. You can add additional ones on top of that, but the expectation is always that those 3 constructors for the exception exist. But we can set up our own additional ones. We can pass in and store additional data there. Other convention with the exceptions is make sure exception is in the name. The rule there is generally, okay, the name of the thing, exception, and that they inherit from system exception. They might inherit from an existing exception type. Maybe that's not a common thing that's going to be done. It's pretty rare. I've not seen any cases where I've needed that. Theoretically, yes, you can, but I would recommend just keeping it inherited from system exception. So key takeaways beyond that with exceptions, we need to remember that when they occur, the rest of our code does not run. And that if that happens very deep in the hierarchy, then a huge amount of code may not run until it gets up to a point where finally that exception is caught. So exceptions, when you see them, fix them immediately. Don't leave them lingering there in the code. If we need to catch exceptions, we can use a try catch block. We can have multiple catch blocks. And again, good practice there is to catch the specific exceptions you need and then have a fallback where for anything else, you just rethrow those exceptions so that they go through the normal process, just so that you're not accidentally silencing exceptions that might be happening that you're not catching. The other thing is don't just start wrapping everything in a try-catch block. That's not the intended approach for working with exceptions. We use try-catch blocks when we expect that an exception may occur and when we need to do specific handling for it. As I said, things like web comms, stuff like that, use exceptions as ways of indicating, hey, a communication error occurred. There was a timeout, there was an error downloading, there was an error sending, things like that. Those we use try catches for because we need to do specific handling because we don't want it to crash out our program. We want to recognize that it's happened, inform the player, the user, and give them agency to fix things. So try catch we use when we expect an exception to happen and when we need to manage what happens in that scenario. To throw an exception, it's really easy. We just use throw and create a new one of that exception. If possible, we use our built-in ones. There's a lot of built-in ones there under the system namespace. So where possible, use an existing built-in one. If we need to, though, we can set up our own custom ones. But the key thing is make use of exceptions when something is wrong that is critically wrong, something where this problem has occurred and we should not keep running. That's the general way that I would recommend treating exceptions is this is a signal for everything's broken, you must stop, you must fix this, it is not safe to continue running the program. It's a way of indicating very severe, very serious errors. So that's a good sort of way of how I recommend approaching using them. So I hope you found the video helpful, folks. If you have found it helpful, please do chuck in a like and subscribe. It really does help out. If you're looking for the code for the project, the code is available up on GitHub, and that code, as with all of the projects, you're freely available to use that at any of your own projects, whether those are commercial or non-commercial ones. If you've got any questions, do chuck in a comment below. And if you're looking for other ways to support the channel, I do have a Patreon, and the link for that's also in the description below. But until next time, bye.